This lesson is Introduction to Object-Oriented Programming. Now, the objectives for this lesson are to see an overview of all the different terms. We're going to talk about the differences between classes and objects. We'll talk about properties and methods, access modifiers, constructors, and destructors. Now, this particular lesson is all slides, but don't worry, I'm not mostly slides. In the further lessons that we're going to cover, you'll see that it is mostly demos. But please do take time to go through this lesson, as the terms I'm going to explain in here will then make more sense later on in this course. Let's start out with what is a class. Now, a class is simply a template that defines the behavior of an object. Now, classes contain definitions. The definitions of the data itself, or properties, the methods, or the behavior of acting upon those properties, and even can be events. Now, this is reactions to things that may occur within the class. So we think of a class as like the blueprint of a house. Now, when you're naming classes, when you create the name for your class, classes are typically expressed as nouns or noun phrases. So example, customer, person, product, etc. We use Pascal casing, as you can see here, so uppercase letter to start. So customer, not customer. We also use a singular, so customer instead of customers. The reason why is because later on we might want to use a collection class called customers. Another example would be product instead of products. Now, when you're naming them, you must begin with a letter. You then can have any amount of letters, numbers, and underscores after that first letter, and up to 255 characters long to make up your class name. Now, the question you might be asking is, well, what should I make a class in my application? Well, any physical item that you're modeling in the real world can probably be a class, such as a house, a car, a person, a bank statement. Could also be a technical concept as well, such as a table in a database, a file in a folder, or even an email. Now, each of the items I mentioned have data, and you can perform some operation on them. If you can come up with those two things on a physical item or a technical concept, it will probably make a good class. So for example, take our house analogy. You'd probably have properties for the number of windows and properties for the number of doors and handles and cabinets. You might have some methods like set construction date, set permits. For our table in a database, well, it has columns. It has the number of rows that are in the table. It might have methods such as insert, update, and delete. So hopefully that gives you a pretty good idea of what you should make a class in your application. So what is an object? An object is simply an instance of a class. It's the logical entity that you are going to program against. It's the thing that exists in memory. With each object, you can then set properties, you can call methods, you can respond to or raise events. So we think of the house itself as the thing that is built from the blueprint, right? The class, that's the object. So a house is an object, a class is a blueprint. We refer to objects in code just as we would with any type of variable we're going to create. So for example, I have a string name. Name is the actual variable name. Well, if I have a product class, we can call it whatever we want. I'm going to call it entity in this particular instance. When you're creating objects, you instantiate that object, which means you're creating and setting aside memory for that object. We use the new keyword to instantiate that object. And there's actually 4 different methods of doing this. The first one is the first 2 lines here, product entity, entity equals new product, or all on one line, product entity equals new product. You can also use the var keyword, which will infer the type by looking at the right-hand side there of the equal sign and figuring out that you're creating a new product. And then the new shorthand way, starting with .NET 6, is product entity equals new. As long as you define product on the left-hand side, we can shorthand this to simply new. It is important to understand the differences between a class and an object. So a class is a blueprint or a template. Object is an instance of the template. So you can't live in a blueprint, but you can live in a house. You can't interact with a class, only an object. When we create properties, they are going to describe the attributes of an object. For example, a name, a first name, a last name, a social security number, a salary, things like that. Describe the data that this object is going to hold. So the template defines the properties, and then the object is where we are actually setting and supplying the values to anybody who needs it. So each object maintains its own data storage. So here I've got on the left-hand side, product prod1 equals new, prod1.name equals bicycle. So prod1 is a separate variable and it holds an instance of a product class. Then on the right side over here, I do product prod2 equals new, prod2.name equals helmet. So again, a separate entity in memory. So these are the objects that are being created from the class. Now, methods are procedures defined by the class. They can return a value or not return a value. Either way, doesn't matter. Customer entity equals new, and then I set the company name, the first name, and then I call a method that simply sets a salary, but it doesn't return any value. However, the next one, entity.insert, yes, that will return a value back, and you can see it being assigned on the left-hand side of that equal sign then. Access modifiers allow us to limit the scope or the visibility of properties and methods. There are four basic types. Public, which means that property or method is accessible anywhere. Private, it's only accessible within the class. Internal, it's only accessible within the assembly in which it's defined. And protected means that property or method is only accessible within the class and any classes that inherit from that class. Namespaces are also very important in object-oriented programming as they allow related types to be grouped into namespaces, which means they can easily be searched and referenced. Think about when you walk into a bookstore. If they just had books all over the place, how would you ever find a book you're interested in on a particular topic? Instead, they label them fiction, science fiction, travel. So that's the namespace, and then all of the books underneath it are the classes that are organized into that namespace. So the first part of the name up to the final dot is the namespace name. So in this case, system.windows.forms. And then the final portion there is the class name itself. So form is the class name. Events are something that objects can raise and respond to. So some examples might be closing, loaded, lost focus, mouse move, customer processed, product read, things like that are examples of events that you're either going to be raising that other people can then respond to, or you're going to be responding to those events that happen. Let's talk for a minute about static versus instance. Now, some classes provide both static and instance members. A member could be a property or a method. Instance members belong to each instance of a class or an object. Static members belong to the class and not any one specific instance. Instance members are methods that are called on each object. So product entity equals new. So our object is entity. We set entity.name equal to bicycle, and then I invoke the insert method on that entity object itself. Contrast that with a static member where the method is actually called on the class itself. You do not need to instantiate the product class. You can simply do product.calculateProfit. You pass in a couple of parameters usually, and you get some value back. There is no need to have any data in the product instance. We're just going to use the product class's calculateProfit static method and get the values back. Let's talk about constructors. Constructors are simply a method with the same name as the class itself. The .NET runtime calls this method automatically whenever the object is first created. So inside of this method is where we might perform some initializations. You may also pass data to that constructor. You just add parameters to the method. By default, there are no parameters. And here's an example of just adding parameters to the constructor method. So on my product entity, I would do entity equals new, but then I would pass some data to it. Maybe I'm passing just a single string, or maybe I'm passing a string plus 2 decimal values. As there are constructors in a class, there can also be destructors in a class, and these are the dispose and finalize method. Now, dispose is where you will release any what are called unmanaged resources, which I'll talk about in just a second. Now, the dispose method is up to the programmer to call. If the class has a dispose method, you should always be checking to see if it does, and if it does, call it. The finalize is called by the garbage collector. It's unknown when this finalize method is called, but it will happen at some point. It happens usually after the last reference to the object is released. Typically what you do is you call dispose and the finalize to make sure everything is released in just one place. One term I mentioned there was unmanaged resources. .NET is managed code. The Windows API is unmanaged code, which means there could be some issues if you don't do something right, whereas .NET is taken care of to make sure everything is done correctly. Now, if your .NET object has to use unmanaged resources for some reason, maybe file handles or window object handles because you're doing something directly down with the Windows API, you can do that. That is fine. However, it is really recommended that you create these resources in the constructor and that you release them in the destructor. And of course, that could be either the dispose or the finalize. Highly recommend using the dispose. Okay, I know that was a lot of PowerPoints. Thanks for sticking with me there, but we are going to be doing mostly demos from here on out. In this lesson, we saw how it's really important that you're always building classes and applications. You're going to add properties to hold data in your classes. You're going to add methods to manipulate or load the data into those properties. And you're going to take advantage of the many different .NET classes that we'll see throughout this course. So coming up next, we're going to talk about using properties to hold data in your classes.